Okay, so we're going to go over properties of quadratic functions. First thing they've done is they've given you coordinates on a graph. Okay? Now they've written them out in table form. We can graph these points and get an idea of what this is going to make, or we can do something called differences, okay? And first and second differences. First differences is when you take the y values and you subtract them from each other to find the difference between them, and then that number means something. Now, in order to do this, we have to make sure all of our x values are changing at the same rate, okay? And this one, what it's going up by 1 every single time, right? We're going plus 1, plus 1, plus 1, so we know this will work. So always just double check that. If your x values aren't going up at a consistent number, we can't actually use first differences. We'll have to find out what that consistent value is. So what we do for first differences is we just subtract, essentially. That's what differences mean. So we take, and it doesn't matter what order you do it in, just as long as you stay consistent, whether you subtract the top from the bottom or the bottom from the top. Okay? And what we'll do is we'll just quickly show you how that works. So I'm making an extra chart here. I'm going to take the top from the bottom. So in other words, what I'm going to do is I'm going to take the number 15, subtract 11, and I'm going to get what? 4. Okay. Now if I did vice versa, 11 from 15, what would I get? Negative 4. Okay? So this is important. I'm just going to put that as a side note here. On the next one, we're going to do 11 subtract 7. What we will get? Okay? And what if I did vice versa? Okay. Next, we'll do 7 subtract 3. And, yep. And then finally, 3 subtract negative 1. Yeah, and negative 1 subtract 3? 4. Yeah, okay. So, our first differences were all the same. This is very important. That means we can stop here. Okay, if first difference is the same, that means we have a linear equation. Okay. And in other words, what they're saying is, we will quickly draw a small graph here. We have something that goes like that. It's linear. Straight line, okay? It's not quadratic. Had these all been differences, and notice when we did the other way, they all ended up being the same also. So it didn't matter if we did top from bottom or bottom from top, we still got the same numbers, okay? Now, in order for something to be quadratic, our first differences can't be the same, okay? And what I would mean by that is, if they're not the same, we would then take their values and we would subtract them to find something quadratic. That's called finding the second differences. It would be the exact same process, but in our first differences, we wouldn't have values that are the same. We'd have something like 5 or 7 and 5 and 3 and 1. They'd all be different. We would then take those values and subtract them, and if they were the same, then we'd have a quadratic. Okay? So, let's, for argument's sake, say that our first differences weren't the same in this one. So we'll quickly change all the numbers in this one. Okay, so here's another example. We'll do first differences. First of all, my x values, they're all increasing by 1, so that's very convenient. They're all changing at the same rate. That's important. So first differences. Remember I said how we could do it the opposite? Let's do the bottom from the top and just prove that. So negative 14, because there's differences, subtract negative 32. When we do that, do you know what we're going to get? It's going to be the same as negative 14 plus 32. I'll do it here. So 14 negative, subtract 32 negative, 18. Okay? We'll just stay consistent now. Take the bottom from the top, 0, subtract negative 14. What's that going to give us? 14. Yep. 10, subtract 0. And 16, subtract 10. Okay. Now, are the first differences all the same? No. So this one is not linear. Okay? We know that. Now, just because it's not linear doesn't mean it is quadratic. It could be neither in our our cases. But what we're going to do is find the second difference now and see if these are the same. Now, if these end up being the same, that means we have a quadratic function. If they're not the same, then we don't have a linear nor a quadratic function. So second differences. Let's go bottom from the top again. 14 subtract 18 gives us 10 subtract 14. Yeah, you're right. Negative 4. 10 subtract 14. And 6 subtract 10. So, because our second difference is the same, we have a quadratic. And what that means is if we were to quickly do a graph here, we have some function. If we were to plot them all, we're going to get something like that. Okay? We're going to get a parabola or a quadratic function. So, without graphing things, that's how you can tell by using tables. Okay? That's how you can tell using tables if something is a linear equation or it's a quadratic. It's a quadratic.
And K was like there sometimes.
Yeah, exactly. So for a quadratic equation, actually, let's it should be quadratic. Because you have done all those transformations before, we have a K function here. Now, a lot of times with quadratics, C, yeah, that's right, and D. Okay, and then technically that was within there. This is all within that function. Oh, sorry, no. Brackets here. There we go. So he's in there. So the quadratic function, it's the same as any other function in terms of our values. We know A deals with vertical, okay, stretches and compressions, where if A is greater than 1, it's a vertical stretch, right? If A is between 1 and 0, it's a vertical compression. And if A is negative, it's a what? Flip on what axis?
The
X-axis. Good. All right. Let me just move this up here. Nope. I want to put it right underneath. So this is A, up and down, we know. What's K deal with?
the horizontal stretching.
That's right. So if K is greater than 1, what do we get? Whoops. K is greater than 1, what do we get?
It's a horizontal stretch.
Yeah. A compression. This is what we use, yes. Yeah. Because what ends up happening here, in this case, is we multiply by A, right? Multiply by A, and we multiply by negative A. Okay? In this case, we're actually multiplying our x value by 1 over k. Okay? So, and if k is less than 0 and greater than 1, we have a horizontal stretch. Does little quotations make sense to you? Okay, it's because we're multiplying by 1 over k, which makes it a greater number. And if k is a negative, what do we get?
Flip on the
Y-axis. And then finally, C deals with movements left and right. Now, because remember the rule is this is a negative, right? Technically, we usually look at this number as the whole thing. Like if this was negative 6, we would say it's shifted to the right 6. But technically, we've plugged the number positive 6 in there. Okay? So when I write these rules, I want you to be aware that I'm referring to the operation in front of the number also. Okay? That's really important when I go to write these rules. So if C is negative, we go right in a positive direction. Okay? Does that make sense?
Yeah.
If C is a positive number, we go left in a negative direction. And finally, D deals with up and down. It's the same idea, except that D is positive. We go up, positive direction, and if d is a negative number, we go down in a negative direction. Do those rules make sense to you? Okay, so with that information, you should be able to solve all the quadratics. All it is moving parabolas in those ideas. So take a look at those questions you have. So along with that, when a is positive, opens up, or in other words, like this. When a is negative, opens down. Sad face. Okay, this is a function. That models a ball being thrown in the air. Essentially, it's an upside down parabola, right? Because our a values are negative. So we have something like that. Now, let's see. The question is asking us quite a few things. At one point, they want to know where the ball starts. When the ball's starting, they're talking about when t is what? It hasn't been thrown yet, let's say. 0, that's right. So when at 0, we would plug 0 in for all the values of t. Okay? So we'll do it in red here. 0, 0. So we have squared plus 20 times 0 plus 25. So our h at 0 ends up becoming 0 squared is
0.
Times negative 5.
0.
20 times 0
0.
plus 25. Yeah. So this height, or this ball, is originally thrown at 25 meters in the air. Okay? This is also the same as a y-intercept. Okay? So say I was to quickly graph a small thing like this. When x is 0, we're talking about when we're on the y-axis, right? So what we just discovered is at 25 meters, this is where the parabola starts. Maybe it drops directly down, but it probably does something like that. Okay? This is an example, a rough sketch of what's probably going to happen. Probably throws it up and then eventually starts to drop down. Makes sense because gravity with a ball, right? Now, zeros. Find the zeros. What they mean by zeros is they're talking about when our y is 0, or in other words, the x-intercepts. Zeros are x-intercepts. That's what they're talking about. So let's rename them x-intercepts. And there's several ways to find x-intercepts. One of the best ways, for instance, do you know what form we're in right now? There are 3 forms. We have our standard form, factored form, and vertex form of a quadratic. Which of the forms are we in right now? This one here? Is it in vertex?
Oh. No.
It's in standard. Okay. Now it's very important. Let's actually draw back to what we were doing before. Let's jump back over here. What form was this over here?
That was vertex?
Yes. This is vertex form. Okay. Very important that we recognize that. This is vertex form, just like we have over here. Okay. It's a different form than the next one we're just about to deal with. It's still a quadratic, but it's in a different form. In this one, we're in our standard form. Very important to know the difference between these, okay? Because in standard form, I can't go around finding the vertex right away. It's actually going to be quite difficult. But from standard form, I can find factored form very easily, essentially by factoring. Right? That's why they make us go through factoring. And they will help us find our x-intercepts when we go to factor. So we'll take our equation, height, okay, negative 5t squared plus 20t plus 25. Now, when factoring, what's the first step to factoring these?
The first step is
Yeah, very good. What would the greatest common factor be here?
5.
Just 5? Yeah, we'll probably try to make it negative 5, right? It's always nice to get rid of that negative on the first term. So, we factor that out, the greatest common factor ends up being negative 5. Inside the brackets, we're left with t squared minus 4t minus 5. Now from there, we can work on our factoring. First terms and last terms. So we get 1t, 1t, and we have 5 and 1. We know that their products need to add up to what?
Negative 4.
So clearly we're going to multiply these by each other because they're the only products. So we're going to get 5t and 1t. It's supposed to be 4t. Now in order to make negative 4, what do I have to do?
Make the 5 negative.
Okay, which means the number we multiplied, which was the 5, would have to be negative. Does negative 5 times positive 1 equal negative 5? Okay, so we know we have our right terms. So let's go to plug it in again. We have our h at t is equal to common factor negative 5. That's our a value. Okay, and our first term is just t in one of the brackets, t in the other bracket. And because they're both the same, it doesn't actually matter which one we put in which. So we have negative 5 and positive 1. So I want you to take a look. We've actually just gone into our factored form. Okay. So we're now in factored form. Our a value is negative 5. And the r and the s stand for our zeros, essentially. Okay, or x-intercepts. Now what we would normally do here is we set the height equal to 0, right? Because like we said, we're trying to find when y is 0, when we're hitting the x-intercepts. So that h at t, we now replace that with the number 0. So 0 is equal to negative 5 times t minus 5 times t plus 1. Now, these are all multiplication. I need one of these here to be 0 in order to create a 0. This negative 5 is really not going to do anything. And we can even isolate this by dividing both sides of the equation by negative 5. And if I had done that, let's say I divide both sides of the equation by negative 5, what's that going to create? On the left side, what number will I have? 0 divided by negative 5, do you know?
0.
Yeah, that's right. Oh, I even wrote it in wrong there. But yeah, you're right. We'll end up with 0. So 0 is equal to negative 5, and negative 5 do what? Yeah, well, they create a 1, but you can also call them canceling out. Okay. So now we have t minus 5 times t plus 1 is equal to 0. Now, in order to get a 0, one of these have to be 0. And there's obviously going to be two options. So we have two sets. One could be 0 with different numbers, and the other one could be 0 with another set of numbers. So we're going to set each of them equal to 0. 0 equals t minus 5. 0 equals t plus 1. In this case, t is equal to 5. In the other case, t is equal to negative 1. So when we jump back up here, it turns out negative 1 and 5 will be the two x-intercepts. The y-intercept is 25. We figured that out. Okay. Now, what that means, they might ask us, when will the ball hit the ground? Something like that in terms of a question. Now, would the ball hit the ground a second before I threw it? Would that be a logical answer? No. What's probably going to be the answer? Yeah, probably after about 5 seconds of being in the air, the ball is going to hit the ground. Okay. So we've hit the ground now. Now, there's a couple other things we need to look at here. It's important that we see. We need to look at an axis of symmetry. Okay, we've done something like that over here. Axis of symmetry. That is, we might want to find the peak of the ball. They might go, well, what is the highest point the ball actually hits? Okay. In other words, they're talking about the vertex. Now, in order to know the vertex, we need to know the axis of symmetry, which is the line that cuts the parabola in half. So we have a formula here. Axis of symmetry is r plus s divided by 2. Now, from our factored form, they're referring to factored form. They're essentially asking for our two zeros, for the axis of symmetry. Okay, so we'll do that in red. AOS we'll call axis of symmetry, which is r plus s divided by 2, which means we take 5 plus negative 1 minus 1 divided 2. So what's our axis of symmetry going to be? 3. We get 4 divided by 2. That's right. So, again, what we've now discovered is I can draw a line right down the middle of this parabola, and this is at the number 2, which makes sense. That's halfway between negative 1 and 5. That's also going to be the x value of our vertex. The x value of our vertex. So after 2 seconds, if we're talking about this, right, because this is time in seconds, and this is height in, say, meters, right? After 2 seconds, the ball is going to reach its max height. We don't know exactly when that's going to be. What I need to do now is take this x value of my vertex and either plug it into the standard form or I plug it into the factored form and find out what that height will be at that time. Okay. So, what that means again is we plug 0 into this equation. So let's go back to the original one. We'll go back to our standard form of the equation and we'll plug the number 2 into it. Okay. So, try to waste too much space here. But our height, h at t was equal to -5 times t squared plus 20t plus 25. We're trying to find out at 2 seconds, right? Because that's when the ball's going to hit its highest height, what the height's going to be. So we're going to plug in h at 2 seconds. So we're going to replace all the t's with the number 2. Figure out what that's going to be. Plus 20 times 2 is 25. So, in our first step, what is 2 squared going to be? 20 times 2? We got plus 25. What is -5 times 4? Yeah. And we got our 40 plus 25. What would that be? So what's the max height going to be? So our vertex is at 2 and 45. Or in other words, after 2 seconds, the ball reaches a max height of 45 meters. He's essentially thrown it 20 meters from where he started. After 5 seconds, this ball will again hit the ground and be at 0. So, we did a lot of steps there. A lot of different things we can find out about a parabola. We went from our standard form, into our factored form. We didn't even touch on vertex form. There is a way to go from standard to vertex form. It's called completing the square, but we haven't gone into that quite yet. Okay. But we can find out everything we need to know from standard form by putting it into our factored form. We can find the vertex. And now that we have the vertex and we have an a value, I can essentially create a vertex form. What is my vertex here? Zoom back in again. Well, 2 and 45. Okay, so let's talk about that. Let's say I got to reconstruct it in vertex form, they tell us now. Okay, so I got to make a vertex form. Vertex form is our y equals. Now, if you notice, I didn't put a k in. Okay, we don't really need a k when we're dealing with the parabola for this one here. So let's talk about just a x minus h squared plus k. Sorry, you use different letters. C and d. I know on the side there it says h and k. You're going to use x minus c and d, being the same things as our h and k. Now, we found the a value when we took that common factor out. What was that common factor we took out a while ago when we were factoring? -5. So that is our a value. Okay, we discovered that already. Our a value is -5. The vertex was at 2 and 45. So for my c value, I would plug in the number 2. And for my d value, I plug in the number 45. So my equation is going to read f at x or y is equal to -5, x plus or minus 2. Sure. We're plugging in positive 2. So it would look like this. Yeah, that's right. 45. So we're going to get y is equal to -5, x minus 2 squared plus 45. So we've just gone from standard form. We've just gone from standard form into factor form, and with all the information we gathered, we can create a vertex form. So we have 3 different forms there. We started in standard, got factored halfway, and finished with a vertex form. So I'm going to jump down to that vertex form again, the very bottom. Okay. This vertex form here, I'm going to change it to standard form. So I'm going to go on a new page. Just remember. Okay. Factored and vertex form. they're both telling me, let's say, that I need to go to standard form. Okay, so what that means is I need to expand and simplify. So in this question here, I have negative 5, x minus 2, times x minus 2, plus 45. I FOIL, so this becomes x squared. Can I jump right to negative 4x? Are you okay with that?
Yes.
Plus 4. So I already collected those like terms because I did x times times negative 2, which is negative 2x, negative 2 times x, which is negative 2x. So I knew it was going to combine to be negative 4. All right? And then negative 2 times negative 2 gives me positive 4. Right? So I kind of jumped ahead there. Plus 45. Then I multiply that 5 into everything. So I get negative 5x squared plus 20x minus 20 plus 45, which gives me negative 5x plus 20x plus 25, which is exactly what we had started with when we were in our standard form. But let's just make sure we can do it both of them. Exact same idea. Let's FOIL. Here I'm going to get x squared minus 5x plus x minus 5. That makes sense?
What did you just do?
So I did
Oh, you took.
times this guy and this guy. It's the same thing I did on the other side too. I'll just go back up just to double check with you. Okay. So what I did is I took x times both terms, and I took the second term times both terms. That's what I had done in there. Okay. So now that I've done that, I collect those like terms inside. I get x squared minus 4x minus 5. And when I distribute the 5, which is the same thing I had done before up here, where I did the 5 times all 3 of those, I'm doing 5 times all 3 of these numbers, I'm distributing the 5. We get negative 5x squared plus 20x plus 25. So if you take a look, there you go. Dual pages, and technically the exact same thing we'd started with in our standard form. Well, it's going to take a long time to fill that out. But that's it. See how we went back to our standard form? So we expand and simplify from either vertex or factor form to get back to standard form.